Welcome to homework.
So to begin our question, we're asked for part A, in terms of n and other sphere and the sphere radius r, what is the distance between the image produced by the sphere and the right side of that sphere? So to do this, we're going to have the relationship between the object distance and the image distance given as follows. Let's indicate this as part A. We have index of refraction 1, n1, divided by the distance to the image I, plus n2 over p is equal to n2 minus n1 over r. Okay, but here we're going to consider p going to infinity. So the image is coming from infinity, or excuse me, the object distance is coming from infinity. So this is going to go to 0. So what we end up with is I is equal to n1 times r divided by n2 minus n1. So here we're going to let n1 equal 1. We're going to let n2 equal n. And the value of n is between 1 and 2. So n2 is between 1 and 2. If this is true, then I has to be greater than 2 times r. So the image does form before the ray strikes the opposite side of the sphere. So we can still consider this as a sort of virtual object for the second imaging event, where this virtual object's distance then is given by 2r minus 1 is equal to n minus 2 times r divided by n minus 1. Where we have simplified the notation, again, by writing n2 is equal to n here, and putting this in for p in equation at the very beginning. So we go back to our beginning equation where n1 over I plus n2 over p is equal to n2 minus n1 over r. But now we're not going to let p equal infinity. We're going to let p equal 2r minus 1. So for this part, p is equal to 2r minus 1. Therefore, we'll call this a p prime, right? So we have n1, which is just 1. So we can just write it as such. We have 1 over the new image, we'll call I prime, plus n over p prime, which is 2r minus 1, but 2r minus 1 was equal to n minus 2 times r divided by n minus 1. So we can just plug that in. So we end up with n divided by n minus 2 times r divided by n minus 1. And this is equal to n2 minus n1, which is n minus 1 divided by r. So we can rearrange here. We're going to try to solve for I prime. So we have 1 over I prime is equal to n minus 1 over r minus n times n minus 1 divided by n minus 2 times r. So I just rearranged that above equation and I simplified the term there. Here, I'll circle it. I just simplified this term here by taking the value that's at the very bottom and bringing it up to the numerator. Okay, so we can continue to simplify this, and what we have is n minus 1, because we need to get a common denominator, and that common denominator is going to be n minus 2 times r. So this is going to be n minus 1 times n minus 2 divided by n minus 2 times r. And since they have a common denominator now, we can go ahead and use that common denominator, and we subtract n times n minus 1. So we're going to go ahead and carry out those operations in the numerator there. So we have 1 over I prime is equal to n squared minus 2n minus n plus 2. So we carried out n minus 1 times n minus 2. And then this is going to be minus, now we're going to carry out the operation n times n minus 1. So this is going to be minus n squared plus n. And this is all still divided by n minus 2 times r. So we can do some simplification here. Let's cancel out some terms. So this n squared cancels with this minus n squared, right? This minus n cancels with this plus n. So what are we left with? We're left with this equaling 2 minus 2n divided by n minus 2 times r. Which is equal to negative 2 multiplied by n minus 1 divided by n minus 2 times r. So we need to simply invert these equations to solve for I prime. So now we find that I prime is equal to 2 minus n times r. So I'm just distributing that negative sign in front of the negative 2 through that value to get rid of that negative sign there. So this is 2 times n minus 1. And we can go ahead and box that in as our solution for part A. Part B says, is the image to the left or to the right side? So the image is to the right side of the sphere, and we just have to look at the value for I prime. And since I prime is going to be positive for any value of n between 1 and 2, right? No matter what n is, as long as n is between 1 and 2, so it's greater than 1, less than 2, I prime is positive. So we can say that I prime is greater than 1, or is greater than 0. It's greater than 0. This is part B. So because it's greater than 0, thus, thus it is to the right side of the sphere. And we can box that in as our solution to B in the final part of the question.